Welcome back to Cosmos in a Pod, Space and Astronomy series, of course. Um, Today we're going to be diving deep into something I think will leave you terrified, but also, like, completely in awe. Supermassive black holes, ready to go explore.
Always. Always ready to for a cosmic adventure. What kind of mysteries are we uncovering today?
Well, we're not just talking about, your average black holes. We're talking supermassive black holes, the kind that are like millions, even billions of times the mass of our sun.
Ah, yes, the cosmic heavyweights. They're really something else.
Exactly. And here's the thing. They're not just like passively sitting there in the centers of galaxies. They're actively shaping the galaxies they inhabit, almost like cosmic architects.
Yeah, that's what's so fascinating, right? Their influence stretches way beyond just their immediate surroundings.
Now, before we get too far ahead of ourselves, let's take a step back,
Oh,
right?
sure.
For anyone who might not be totally up to speed, can you break it down for us? What makes a black hole supermassive?
Yeah, sure. So you're probably familiar with the basic idea of a black hole, a place in space where gravity is so strong that nothing, not even light, can escape. A supermassive black hole takes that concept and dials it up to 11. We're talking objects with masses millions or even billions of times greater than our sun.
Wow, so that's a completely different scale.
Oh, absolutely. And all that mass equals some serious gravitational pull, the kind that dominates entire galaxies.
So it's not just about size, it's the impact, the influence it has on everything around it.
You got it. Think of our solar system, but instead of the sun in the middle, you've got this supermassive black hole dictating the movements of stars and gas clouds over these incredible distances.
Wow, it's almost impossible to picture.
Yeah.
But how do these things even form? I mean, where does all that mass come from in the first place?
Well, that is one of the biggest questions in, well, all of astrophysics. We're talking about a cosmic mystery shrouded in darkness, pun intended. One theory is that they formed directly from giant gas clouds that collapsed way back in the early universe.
So they basically skip the whole star phase and just go straight to black hole.
Boom, right to black hole status. It's like, I don't know, going from a grain of sand to a mountain in a single step. Another theory is they start out smaller, maybe leftovers from dead stars, and then they just gradually grow by pulling in stuff around them.
The cosmic vacuum cleaners just sucking up everything in their path.
I like that analogy. And of course, we can't rule out the possibility of mergers, smaller black holes colliding and combining over, well, billions of years.
So a combination of things happening like forever.
It's a complex process, a puzzle we're still piecing together, but it's definitely one of the most fascinating puzzles in astronomy.
I know we tend to think of black holes as these like destructive forces, but I've heard they actually play a pretty surprising role in shaping galaxies. Is that right?
It's true. They're a lot more than just cosmic vacuum cleaners. They actually act as regulators, influencing the life cycle of stars within their galaxies.
So they're not just destroying things. They're actually contributing to the creation of new stars.
That's the amazing part. It's a delicate balance. They can trigger star formation and they can suppress it. It all depends on the circumstances. It's like they have this cosmic thermostat fine-tuning the conditions inside their galaxies.
Okay, now I'm really interested. Tell me more about this cosmic thermostat. How does it work?
Oh, one of the key processes is something called feedback. When a supermassive black hole is actively feeding, pulling in huge amounts of gas and dust, it releases this enormous amount of energy.
So it's like a cosmic engine with all that fuel creating this powerful output.
That's it, yeah. And this energy comes out in different ways. Powerful jets of particles, intense radiation.
And this is what affects star formation.
Yeah, so picture it like this. These jets, they can heat up and even push away the very gas and dust that would usually clump together to form new stars.
So basically, the black hole's activity can actually prevent star formation in some areas.
That's right. It might seem counterintuitive, but these forces, these destructive forces, they play a vital role in regulating the pace of star birth in a galaxy.
That's incredible. Are there any other feedback mechanisms? Like, what else is going on?
Oh, there are. Even when a black hole isn't actively feeding, it can still exert a more subtle form of feedback. Imagine a gentle breeze compared to a hurricane. This kind of feedback can gradually heat the surrounding gas over very long periods, preventing rapid star formation. It leads to a slower, more gradual evolution of the galaxy.
So it's this constant give and take, this interplay between the black hole and everything around it, shaping the galaxy over billions of years.
Exactly. A dynamic dance that, we're still trying to figure out all the steps. And it's not just star formation.
Really? What else is there? What other roles do these black holes play in shaping their galaxies?
Supermassive black holes, they have this profound impact on the entire structure of their host galaxies. Their huge gravity, it pulls in stars, it pulls in gas, creating these dense central bulges that we see. They even influence a galaxy's shape, whether it becomes a spiral like our own Milky Way or an elliptical galaxy.
So they're like cosmic sculptors, shaping the distribution of matter in a galaxy over vast periods.
I like that, yeah. They're not passive observers, they're active participants in this grand evolution of galaxies.
Wow, this is like so fascinating. It makes me wonder, are there any specific examples of these supermassive black holes that really show their power and their influence?
Oh, absolutely. There are some real celebrity supermassive black holes out there.
Okay, I love a good cosmic celebrity story. Tell me more.
Well, right in our own cosmic backyard, the center of the Milky Way, there's Sagittarius A, a supermassive black hole about 4 million times the mass of our sun.
Hold on, so our own galaxy has one of these at its center.
It does. It's pretty quiet compared to some of the others out there, but still incredibly fascinating.
It's amazing and a little scary, isn't it? What about some other famous examples?
Well, one that really captured everyone's attention a while back is the supermassive black hole in the galaxy M87.
Oh, right, that incredible image, the first picture of a black hole shadow.
That's it. That image gave us the first direct proof of something that was once considered purely theoretical, the event horizon, the point of no return.
It was such a powerful picture. It really makes you think. It's a reminder of just how mysterious and powerful these objects really are.
Absolutely. And then there's TON 618. This one's a true monster. It's in a distant quasar, and it weighs in at a staggering 66 billion solar masses.
66 billion? I mean, how is that even possible?
It makes our own Milky Way's black hole look tiny, doesn't it?
These examples are truly remarkable. But it makes me wonder, how do we study something we can't see? I mean, they don't emit light, so how do we even know they're there, let alone learn anything about them?
Well, that's where things get really clever. We can't see them directly, but we can see how they affect things around them.
So it's like a cosmic detective story, looking for clues.
Exactly. One way is by studying the movement of stars and gas clouds that are orbiting around them.
So we could literally see these objects being like whipped around by the black hole's gravity.
Exactly. And we can also detect the radiation that's emitted by all that superheated matter spiraling into the black hole.
It's like listening to the black hole song, decoding its secrets through the different frequencies of light.
And in recent years, we've got this amazing new tool, gravitational waves.
Oh yeah, those ripples in space-time that Einstein predicted. Do those help us study supermassive black holes?
You bet they do. Detecting gravitational waves from merging black holes has opened up a whole new way of looking at the universe. It lets us measure the masses and spins of these black holes with incredible accuracy.
It's amazing to think that we can study these things in so many different ways. It's a real testament to human ingenuity.
Absolutely. And yet, for everything we've learned, there are still so many mysteries surrounding these supermassive black holes.
Oh, I bet. What are some of the big questions that scientists are still trying to answer? What are the puzzles they're working on?
Well, one of the biggest ones is, how do these things grow so fast? We see these incredibly massive black holes in the very early universe, and it just doesn't quite fit with our models of black hole growth.
So it's like finding a fully grown oak tree in a forest that's only a few years old. Something's not adding up.
Right. And then there's the relationship between supermassive black holes and dark matter.
I've heard of dark matter, this mysterious stuff that makes up a huge part of the universe. But how does it connect to black holes?
Well, we know that galaxies are surrounded by these vast halos of dark matter, and it's looking more and more likely that there's this kind of dynamic interplay between the dark matter and the supermassive black holes at the centers of galaxies.
So they could be influencing each other, like one affecting the other.
That's the idea. Some theories suggest that dark matter could even be fueling the growth of these black holes, providing a steady stream of, invisible food for them to consume.
A hidden food source for these cosmic giants.
Exactly. It's still early days in this research, but it has the potential to change how we understand both dark matter and supermassive black holes.
This is just mind-blowing. It seems like every answer we find just leads to more questions.
That's the fun part. It's a constant journey of discovery.
Exactly. Speaking of unanswered questions, is there anything else about these supermassive black holes that is still stumping the scientists?
One more big puzzle is the possible existence of something called intermediate mass black holes.
And those are.
So we know about the stellar mass black holes, right? The ones that are a few times heavier than our sun. And we have the supermassive ones, the ones that are millions or billions of times heavier. But there seems to be this missing piece in the middle.
Like a missing link.
That's it. We haven't found any solid evidence of black holes with masses in between those two extremes, the kind that would bridge that gap.
So it's like a cosmic treasure hunt then.
Exactly. Maybe they're out there hiding in plain sight, or maybe there's something about how black holes form that just prevents them from forming at that size. It's a mystery, and astronomers are still searching for the answer.
It's incredible to think about how much we still don't know about these objects. They really are like windows into the most extreme parts of the universe.
And they push our understanding of physics to the limit, that's for sure.
This has been an incredible journey so far. We've covered so much, from how supermassive black holes form to their effects on galaxies and all the mysteries surrounding them.
It's been a great discussion, and we're just getting started.
That's right. But we'll have to pick up where we left off next time.
Don't worry. In our next deep dive, we'll be exploring even more mind-blowing aspects of these amazing objects, ready to jump back into those cosmic mysteries.
You bet. Last time we were talking about those intermediate mass black holes, you called them the missing link in the black hole family tree. Have there been any new discoveries, anything exciting happening on that front?
Oh, yeah. It's a really hot area of research right now. Lots of tantalizing clues and possible candidates popping up. Some astronomers think they might have found evidence for these intermediate mass black holes hiding out in the centers of really dense star clusters.
That makes sense, right? I mean, star clusters have so many stars packed together. Wouldn't that be like the perfect place for a black hole to, grow and like feast?
Exactly, like a cosmic buffet table for hungry black holes. And there's another interesting idea floating around. Maybe these intermediate mass black holes, they could be the seeds for the supermassive ones we see in the hearts of galaxies.
So instead of starting from scratch, these supermassive black holes could get a head start if they begin as these intermediate mass black holes.
Exactly. It's like giving them a boost up the cosmic ladder.
That's so cool. It really paints a picture of this interconnected universe, where all these different types of black holes could be linked across time.
It's a humbling thought, for sure. And it really highlights just how much we still don't know about how the universe works.
Speaking of humbling, we were talking before about the relationship between supermassive black holes and dark matter. I've always been fascinated by that. Can you tell me more about that connection?
Of course. So dark matter, it's one of the biggest mysteries in, well, pretty much all of astrophysics. It doesn't interact with light, so we can't see it.
Right.
But we know it's out there because of its gravitational effects on, the stuff we can see.
It's like this invisible scaffolding holding everything together.
Great analogy. And we think that galaxies are embedded in these vast halos of dark matter.
So these halos, it's like invisible cocoons surrounding the galaxy.
Yeah, exactly. And here's where things get really interesting. There's this growing suspicion that these dark matter halos could be playing a big role in how supermassive black holes form and grow.
I'm all ears. How could something we can't see be influencing something as powerful as a black hole?
Okay, so one possibility is that these dark matter particles, as they bump into each other, they lose energy and start to spiral inwards towards the center of the galaxy.
And then what happens? What happens when they get close to the black hole at the center?
Well, as they get closer and closer to the black hole, they can get so packed together that they form something called it's called a dark matter spike.
A dark matter spike. I've never heard of that. What is it?
Imagine a huge concentration of dark matter just surrounding the black hole, like a dense invisible cloud.
So it's like a hidden food source for the black hole.
You got it. This concentrated dark matter could be getting, devoured by the black hole, helping it grow over, well, billions and billions of years.
So these supermassive black holes could be growing not just by eating stars and gas, but also by feeding on this, invisible dark matter.
That's one of the leading theories, and it really shows you how interconnected everything is, right? Something we can't even see could be having a huge impact on these powerful objects.
It's like a hidden web, a cosmic dance between the visible and the invisible.
Love that. And it really emphasizes how much more there is out there to discover and understand.
This is all so mind-blowing. It makes you realize that we're really just getting started.
Yeah.
And for all the amazing things we've learned about these black holes, there's still so much we don't know.
Absolutely. And that's what makes it so exciting, wouldn't you say? Every new discovery just opens up a whole new world of questions and possibilities.
Speaking of new discoveries, I've been hearing a lot about this thing called the Event Horizon Telescope. Can you tell me a bit about that and what it's doing to help us learn more about supermassive black holes?
Oh, the Event Horizon Telescope, or EHT, that's one of the most ambitious projects in, well, maybe all of science. It's not just one telescope, it's this whole global network of radio telescopes that are all working together.
Ooh, that sounds incredible. Why go to all that trouble to build this, worldwide network of telescopes?
It all comes down to resolution. It's about seeing the fine details. By combining the signals from all these different telescopes across the globe, the EHT can see things in incredible detail, the kind of detail you need to peer right into the heart of a galaxy and see the regions around a supermassive black hole.
It's like having a cosmic zoom lens, right? Seeing things that would be impossible to see otherwise.
Exactly. And remember, a few years back, the EHT captured that amazing image of the supermassive black hole at the center of the galaxy M87.
Oh yeah, the first picture of a black hole shadow. That was a huge deal, wasn't it?
It was a real turning point. It gave us the first direct visual proof that black holes and their event horizons, the point of no return, actually exist. We went from theory to, well, to actually seeing it.
A real testament to human ingenuity and collaboration. And I'm sure the EHT has even more exciting observations planned for the future.
Oh, absolutely. The EHT is constantly getting upgraded and refined, and astronomers are using it to look at other supermassive black holes in even greater detail.
So we can expect even more incredible images and insights into these mind-boggling objects.
You bet. The EHT is going to revolutionize our understanding of black holes, that's for sure.
This is all so exciting. It feels like we're living in a golden age of black hole research, with new discoveries being made all the time.
And it's not just about black holes themselves, right? By studying them, we're pushing the limits of physics, testing our theories about gravity, and getting a better grasp of, well, the basic laws that govern the entire universe.
It's this constant search for knowledge, driven by our need to understand the universe.
Exactly. That's what drives us to invent these incredible technologies, to build bigger and better telescopes, and to work together to solve these cosmic mysteries.
This has been such an incredible journey so far, but I know we're not done yet. We still have so much more to explore.
That's right. Hang on tight, because in our next installment, we're going to go even deeper into the mysteries of these supermassive black holes. We'll be talking about their bizarre properties, their influence on galaxies, and all the mind-boggling possibilities they hold for understanding the universe around us.
All right, back for more cosmic adventures. You've really painted a mind-blowing picture of how powerful these supermassive black holes are, not just in their immediate area, but shaping entire galaxies. It's amazing.
And we're just getting warmed up, trust me. There's still so much more to learn about these enigmatic objects.
Well, let's dive in. You were saying before that studying black holes can really push the limits of physics, right?
Mm-hmm.
Can you tell me more about that? How are they challenging our current understanding of the universe?
Well, one of the most fundamental ways is through their extreme gravity, right? I mean, we're talking regions of space where gravity is so strong that it actually warps space-time itself.
Space-time. I've heard that term before, but can you give me a quick refresher?
Sure, think of space-time as the fabric of the universe, okay? It's this four-dimensional concept that combines the three dimensions of space with the dimension of time.
So instead of thinking of space and time separately, we're combining them into this unified fabric.
That's it. And massive objects like stars and planets, they create a kind of a dent in this fabric that causes other objects to move towards them, which is what we experience as gravity.
So gravity is like a warp in the fabric of space-time.
Exactly. And black holes, well, they take this warping to a whole other level. Their gravity is so intense that it creates this bottomless pit in space-time, a singularity where nothing can escape.
Whoa, it's like a cosmic rip in the fabric of reality.
You could say that. And this extreme warping of space-time, it has huge implications for how we understand physics. It challenges our ideas about cause and effect. Events that happen inside a black hole, well, they might be forever disconnected from the rest of the universe.
That's just, it's mind-boggling. It's like these black holes are rewriting the rules of the universe.
They're definitely making us rethink things. And they're also really putting Einstein's theory of general relativity to the test.
But hasn't Einstein's theory been pretty successful so far?
Oh, incredibly successful. It's predicted tons of phenomena with amazing accuracy. But black holes, they represent some of the most extreme conditions in the universe. And we're not entirely sure if general relativity holds up perfectly in those situations.
So black holes could be showing us, cracks in Einstein's masterpiece.
It's a possibility. There might be some small differences from general relativity in those super strong gravitational fields near black holes. And if we can find those differences, well, it could lead us to a whole new, more complete theory of gravity.
That would be a game changer.
It would be huge. It would change how we understand how the universe works at a fundamental level.
So these black holes are like cosmic laboratories, letting us explore the boundaries of physics.
That's a great way to think about it. And they're also making us ask some really big philosophical questions about the nature of reality, about information, and about the limits of what we can even know.
It's fascinating that something that seems so destructive could also teach us so much.
That's the thing about black holes, isn't it? They're both terrifying and awesome at the same time. They inspire both fear and wonder.
And I think that's what makes them so captivating to so many people, right? They're just so mysterious and powerful. They really grab your imagination.
Couldn't agree more. And as we continue to study them, I'm sure they'll keep challenging us, inspiring us, and amazing us for a long, long time.
This whole deep dive has been incredible. I feel like I've learned so much about supermassive black holes, how they form, how they affect galaxies, the mysteries we're still trying to solve, and how they're pushing the boundaries of physics and our whole understanding of the universe.
It's been a fantastic journey, and it's been great exploring these cosmic wonders with you. I hope our listeners are feeling just as inspired and fascinated as we are.
I'm sure they are. And if you want to, keep exploring the universe with us, be sure to follow Cosmos in a Pod on your favorite podcast app.
And don't forget to check out our YouTube channel for even more mind-blowing space content. We've got stunning visuals, animations, all sorts of stuff that will really bring these concepts to life.
That's it for today, folks. Until next time, keep looking up and keep those cosmic questions coming.